Dear 343 Studios, or Bungie? I mean, I'm talking about stuff that Bungie came up with. Damn it, this is the exact same problem I had last time. Hi, it's me, Austin. You know, I'm having a little bit of trouble deciding between which pre-topic rant to go on. There's the obvious choice of pointing out that the fun I had researching the first Halo video over a year ago was what made me decide to do science full time. But as hot as talking about gamma ray bursts get me, I have to say that my heart carries a heavy burden this week. On average, in the first year of its life, a baby gets sick at least 6 times, but it can get sick as many as 12. Turns out, my baby is an overachiever and has managed to catch not 1, not 2, but 3 separate illnesses in the past 5 weeks, of which I've also been blessed because each time I have also gotten sick as well. Awesome! Turns out being Mr. Mom has its drawbacks, but still, here we are, magically, with a video being made. And on top of it, I finally collected the horrifying poop story merit badge that seems to be a requirement for every parent. I'll spare you the details and leave it up to your imagination how the stuffed animal Zero we picked up from Disneyland during VidCon momentarily resembled Harvey Dent more than an adorably pristine white ghost. Anyway, over a year has passed, YouTube has smoten profanity wielders with content rating chokeholds, PewDiePie continues to be PewDiePie, and finally, after all this time, I have decided to break down the unbelievably cool science of Halo rings. And the science makes... Wait a minute, hold on. Hey, YouTube. Hi, it's me. Okay, never mind. Can you just look the other way for a second? Just over there. Yeah, just do. Okay, and I'm just gonna put these on real quick, just for a second. You got it. Okay, good. The science makes no goddamn sense. That felt so good to say. This has been covered before by a few people, including an essay in the novel about Halo that covers almost every single detail, but got quite a few things freaking wrong. But I'm here to set the record straight. First, let's talk about the basics. Halos are giant rings that float out in space that come complete with rocks, trees, grass, snow, and, most importantly, gravity. We'll get to the gravity thing in a bit, but I have to just loop back to how utterly gigantic these things are. They have a diameter of 10,000 kilometers, which is just 2,000 kilometers shorter than the Earth's. Meaning if Earth decided to go on a diet, it'd make the ideal lap band size. Just enough to curb that massive appetite, but not enough to starve it to death. With a width of 318 kilometers, this gives Halo rings a surface area just shy of 10 million kilometers, or 3.8 million square miles. For context, that's enough space to fit the United States, Iraq, Rwanda, Barbados, and Paris, with just enough space left over to, I don't know, have a tiny national park or something. That means there's enough room to contain the war on terror and a couple of good vacation spots, which is all you really need in life. Aside from being large though, they produce gravity in an utterly fascinating way. Rotation. Specifically, centrifugal force. Now wait, just hold. Stop it. I know the sound of furious keyboard clacking followed by nasally, but don't you mean centripetal force? No, I don't. I don't have time to get into the difference between the reference frames just to satiate your pedantry. Since we're gonna be talking about objects on a spinning ring, centrifugal force is enough for now. Now go whine about it to me on Twitter along with your feelings about photons having mass. Where was I? No, right, artificial gravity. Longtime scientists may recall that gravity is a bit weird in that, yeah, it's definitely a thing, but Einstein proved that there's literally no difference between acceleration and gravity. TLDR, if you're in a box accelerating through space at 1 g of acceleration, or 9.8 meters per second squared, there's no experiment you could run that would be able to prove that you were in a box flying through space instead of in a box sitting on the surface of the Earth. Objects fall light bends, all things are literally exactly the same. This is called the principle of equivalence. There are some problems with this as a long-term solution for gravity in space, however. First, there's the energy requirements. The fuel requirements in order to maintain this rate of acceleration would be somewhere near the order of having a fuel tank the size of a star. Secondly, accelerating at 9.8 meters per second for a long enough time has disastrous space-time complications. In just under a year, you'll have reached speeds at such a high fraction of the speed of light relative to the rest of the universe that effectively you're running a risk of time traveling directly to the point in time that the entire universe dies in a couple of days. In order to get around the relativity problems associated with this constant straight line acceleration problem, enterprising engineers and physicists came up with a secret life hack way of providing constant acceleration without moving in a straight line: rotating rings. And here's how it works. Good old Isaac Newton told us that an object in motion will stay in motion until acted on by an outside force. That outside force is acceleration, and that stay in motion thingy is called inertia. So you're just standing on a rotating ring, right? How? Let's just stop it right there. At this exact moment, your body isn't actually rotating, it's moving this direction, 90 degrees in the direction of the rotation in that exact moment. This is called the tangential vector. Okay, let's start it up again. As the ring rotates, it's pulling you away from that tangential vector at a constant rate. As a result, you constantly feel a change of direction over time, delta V over t, aka acceleration. You feel this force, this tangential force, as gravity, and in almost all ways, it is. You can control the amount of gravity something on the surface of your ring experiences by changing the rotational speed. Spin faster, more acceleration, more gravity. Slower, less, etc., etc. And this is the cool way that halo rings work. However, since this is a dark attempt to hack the laws of physics according to Sir Isaac Newton and my buddy Einstein, it has some serious drawbacks, as is prone to happen when you flirt with the cosmic kraken. But we'll get to that. First, we have to know how fast this thing is spinning. You see, most of the math done on halo rings to date has been assuming a gravitational constant of 9.8, the same as Earth. But if there's something I've learned in my time over analyzing game science, it's to never trust gravity. I love game developers, but I can't recall the last game I played that actually had a gravitational acceleration of 9.8 meters per second. And Halo is no exception. Through a clever combination of frame-by-frame analysis, pixel measurements, and abuse of government-issued equipment, I was able to determine that the rate of gravity on a halo ring is a whopping 15.17 meters per second squared, over 1.5 Gs, which I'm pretty sure you could spend some time on and be mostly okay, but it would kinda suck. I normally weigh about 140 pounds, or more depending upon how recently and how many times I've caved and gorged myself on the local Central Illinois delicacy known as the horseshoe, but on a halo, I'd feel like I weighed 210 freaking pounds. That's a huge difference. Running on this thing would absolutely suck. Thankfully, Master Chief is a super soldier with super soldier-sized glutes. The gravity, however, is the least of the bad news. Oh no, it gets so much worse. And in order to illustrate exactly how, we're gonna have to talk about guns. Hashtag don't flag me, YouTube. Hashtag it's just for the science. The good thing about halo rings is the larger your ring, the less noticeable the negative drawbacks of tangential acceleration gravity you experience, but they never ever fully go away. In order to pull 1.5 Gs, our ring has to rotate slightly slower than 1 rotation per hour, 23.95 rotations per day. And while this seems really slow, your tangential velocity is absurdly fast, 8,711 meters per second, or over 19 19,000 miles per hour. This isn't a huge deal if you're already on the ring, but it makes actually getting on the ring next to impossible. Remember, there's no actual gravity here. You're just experiencing a constant change in direction and speed. That means if, say, you wanted to land on this ring, you'd have to match the rotational speed. You have to get a spaceship rotating at 19,000 miles per freaking hour without managing to crash into the darn thing. With a normal planet with normal gravity, you can just kind of skim the surface using the atmosphere to slow you down. If you tried to do that with a Halo ring, though, you'd be getting slammed by an atmosphere moving at Mach 25. It'd shred even the most well-armored ship to frickin' pieces. You'd be tempted to approach this thing from the side, but I do not recommend this. The best chance you have is starting somewhere near the center and trying to match the spin, working your way slowly inward. Still, this would take forever and be incredibly difficult to pull off. No wonder all the Marines died on impact at the start of Halo 1. A high-speed crash combined with a 1,000-kilogram Master Chief pinballing around the interior of the ship because, like some sort of douchebag, he decided not to wear a seatbelt. Those Marines had no chance. But fine, you're on the ring. All's good now, right? Wrong. The nightmare has just begun, because this spinning ring's worst characteristic for the modern super soldier is its effect on gunfights, which you'll be experiencing a lot of. Running unsanctioned ballistic tests on the Halo ring, I discovered that the muzzle velocity of the assault rifle is exactly 1,000 meters per second. Awesome! That is gonna make my math so much easier. And it's gonna need to be because I have some complicated trigonometry to do. Things in free fall from the surface of the Halo ring experience the worst effects of this tangential acceleration, centrifugal force stuff. The instant you fire a gun, for example, and the bullet leaves the barrel, it is no longer tied to the surface of the ring. Its inertial reference frame, a term for, it's the frame of reference you use to measure physics. Its inertial reference frame leaves the surface of the ring where your inertial frame is and enters the wider galaxy. You see, remember, the gravity is caused by your feet being on the ground and your direction being changed by the rotation of the ring. Your body is wanting to move in the tangential direction, but it's stopped by the ring. But as soon as you're not touching it, you immediately start traveling in a straight line at 8,711 meters per second. If you're just jumping, you'll hit the ground pretty soon, especially under 1.5 G. But if you were moving faster, say if you were a bullet, well, you'll see. The easiest way to see this effect is to fire a round straight up into the air. It's traveling straight up at 1,000 meters per second, but it's also moving at 8,711 meters per second to the left in the direction of the ring's rotation. As a result, for every second, the bullet travels 1,000 meters up and 8,711 meters to the left, ignoring the effects of atmospheric drag. Oh God, the atmosphere. Just wait. We'll get to that. It's not the time yet. What happens if you're looking at the bullet from outside the ring is it travels in a pretty normal ballistic arc. Not exactly mind-blowing, but let's snap to your perspective on the ring. A gun fired straight up in the air will, barring wind, fall straight back down if you're on planet Earth. Well, mostly. The Coriolis effect does exist on Earth, but it's nowhere near as bad as it is on rotating rings. While on Earth, the rotation of a planet can affect the trajectory of a ballistic object by a few inches or feet. On a Halo ring, these bullets end up landing a full 22 kilometers away in the direction of the ring's rotation. This happens for a few different reasons. For one thing, as the bullet travels further away from the ring and closer to the center, it travels further per second in relation to the ground in the direction of the ring's rotation. Kind of like how a figure skater can spin faster by pulling in their arms. But also, there's just the general problem with the ring moving so fast itself. This means that any bullet fired any direction is gonna be affected by this. But as you start firing in directions other than straight up, things get even weirder. I actually had to model these on my computer because the math was far too complicated for me to visualize with just numbers. If you fire your gun at a 45-degree angle in the opposite direction of the ring's rotation, weird stuff happens. I don't have time to get into the complicated math of ballistics, but just, like, here's the math if you're curious. Since a certain amount of the 8,711 meters per second speed is getting canceled out, combined with the ring curving away from the bullet's tangential path, a bullet fired in this direction actually experiences less gravity than a bullet fired in the other direction. A bullet fired at 45 degrees in the same direction as the rotation, as a result, experiences more gravity and falls faster since the tangential speed is getting added to the bullet's horizontal velocity and the ring is curving toward it. However, since the speed of the ring is so absurdly fast, over 8 times faster than a bullet, even though the round fired in the opposite direction of the rotation experiences less gravity, travels higher, and stays in the air longer, it actually travels less distance, since so much of its horizontal velocity is robbed by the ring. By contrast, the bullet fired up the ring hits the ground faster, but travels 21 kilometers further. And a bullet fired perpendicularly to the ring's rotation would curve to the left and right, respectively. And this isn't just a problem for sniping. This problem creates a 30% difference in accuracy depending upon which direction you're firing. You'd basically have to be directly in front of someone to have any hope of hitting anything you're aiming at. And if you fire in the wrong direction at the wrong angle, you risk a bullet meant for somebody else turning around and just straight up smacking you in the face. And then there's the weather. Well, it's possible to contain an atmosphere without a roof. These angular velocity problems would create the weirdest weather ever. Storms would be pretty frequent since the Coriolis effect would be much more exaggerated on this ring than on Earth. But since the rotation is actually perpendicular to Earth, so would the storms be perpendicular to Earth. This means thunderstorms and tornadoes that rotate horizontally. Can you imagine getting sucked up by a tornado that doesn't even touch the ground? The only good thing about this, the only thing, is that bullets could be rendered completely irrelevant because Master Chief, weighing 1,000 pounds on Earth and over 1,500 pounds on a Halo ring, wouldn't have to bother with guns at all. He could just sneak up on the Covenant and jump on their heads like a brutal Space Bro version of Mario. To hell with shooting your enemies. With that jump height, Master Chief is a living weapon of mass destruction, landing on elites and grunts with the force of a European smart car dropped from a building. This is not a place you would want to live. You feel fatter, you wouldn't be able to pour water without spilling it, and just for sheer horror factor, you're also sitting on a WMD capable of releasing 599 quintessilion joules of gamma radiation, over 100 times the energy released by the most powerful explosion ever recorded in our universe, which was a supernova caused by the merging of 2 white dwarves that as a result concentrated too much awesome into one place and had to explode to spread it out again. So, yeah, screw these things. I wanted to live on one when I was a teenager, but I've totally changed my mind. Gunfights are impossible, and you risk getting eaten alive by space herpes just by opening the wrong door. Screw that. This. I'm going back to my cartoon shooting game that has adorable girls with death rays, quantum mechanical teleportation, and sound guns capable of destroying cities. Sincerely, Austin! P.S. Oh, hey, did you know that I came up with a name for those of you who like my show? Scientists! Are you a scientist? Then join my Discord channel. Just follow this link and you can converse with other people who like the show or try to tell me I'm wrong about today. I'm not though. I did the math. Thank you everyone for watching my video on Halo. I hope it does well. I was really excited. I've been wanting to do this one for a while. It's been kind of in my back pocket because I still love the Halo franchise, even after all these years, even though Bungie makes better games than the other ones. Okay, you should subscribe to the Game Theorists if you haven't already, and watch my other videos, watch some map videos, watch some Gaijin Gooba videos. I don't remember what my next topic is for next week, so I'm not going to tell you what it is.